Hi, this is Ken here. I'm trying to go through a little bit of a sample of how to do the natural gas pipe sizing using the longest length method. So I've created a little bit of a PowerPoint that identifies the method, so let's proceed. So the procedure that we should be using is first of all, let's figure out what our longest run is from the gas meter or from the last regulator to that appliance in linear feet. So make sure you are considering when you've got to go up and down or around things to get an appropriate distance. We've got to add up all of those BTUs for that input on every one of those appliances to the gas line. Convert it all to cubic feet. You can either use the example that I'm doing here is 1,000 BTUs a cubic foot. Makes easy math. That's a pretty basic one. Probably in some of my class examples, I might use 1,015 or 1,050. But for a field application, I would really have no problems just staying with the 1,000. So, and obviously from there, we'll enter the table at the longest run, and we won't get out of that again. So very similar to another previous explanation that I had done. So we get all the sizing. We can use that table. We do all the mains, the branches, and we stay on that same row. So let's take a look at an application. So in this particular application, on the far left side, I've got my gas meter that is shown in here on the far upper left side. And you can see how we're progressing through a garage. So when we start looking at our distances, we notice that we've got 8 foot up to the garage ceiling, 15 feet over, 3 feet down, 10 feet down, 3 feet over, and there's a lot of zigging and zagging because of the location of the gas meter. And then of course we've got to pick up a boiler, a water heater, the clothes dryer, the range oven, and all those things, and then a gas fireplace. So let's take a look at the process. So my longest run is going to be the 8 feet up, the 15 feet over, the 10 feet that I've got to go down to get into the building, 3 feet, plus another 3 feet, plus another 46 feet, and another 2 feet to go to that appliance. So the total length of that is 87 linear feet. So that is my longest length. So in this particular case, we're gonna basically take that and do something with it. So let's proceed. So if we start looking at our BTUs of the appliances, we've got 100,000, we've got 50 for the water heater, we've got 35,000 for the clothes dryer, 45,000 for the range and oven, another 60 for that gas log in that fireplace. So the total of that is 290,000 BTUs. So if you remember from any of my earlier discussions, if we take the 1,000, we've got 290,000 BTUs is all the appliances that I've added up. I'll divide that by my 1,000. It comes up to 290 cubic feet of gas per hour that I need to move through that system, certainly from the main. So the table that we are choosing in this case is a 0.3 inch pressure drop. We're using less than 7 inches, less than 2 psi. That's a 7-inch meter in this particular case. So I chose to use 6.2, the piping A or the table A. So the method or the materials we're using is Schedule 40 metallic pipe. So this will be a conventional system that we're doing with this. So now you might remember the longest run was 87 feet. So that means that pushes me down to a 90-foot row. So that 90-foot row is where we're going to stay, and we're not going to end. We're not going to leave that during the entire sizing example. The total input was 290,000. So that means that my initial one, as you can see, is we're going to need to actually go with an 1.25 inch pipe because that has the capacity to handle 322 cubic feet of gas per hour. So initial pipe size, leaving the meter, 1.25 inches. So that one's labeled right here already, 1.25 inches, and we are ready to roll to the next one. Now, this next one here, we're going to actually get rid of 150,000 BTUs right at that T. So we're going to basically venture off of that to catch that water heater and also the boiler. That leaves us with 140,000 BTUs or 140 cubic feet in this example. So if I take a look at the 140 cubic feet, you can see that that is going to allow me to carry the gas over to that section, or what's remaining is actually going to be 157 cubic feet is the capacity in a 1-inch line. So right after we get rid of the boiler and the water heater, we're actually able to reduce down to a 1-inch pipe. So let's go ahead and identify that. So when I do this in the field, I actually will make a quick SketchUp or a drawing like this, very similar, maybe not quite with as much detail on the bedrooms and that, but for illustration purposes, this makes a lot more sense. So 1.25 inch pipe on the main, a 1-inch, we can reduce down to 1 inch after we got rid of 150 cubic feet of fuel. And now we carry that 1 inch the entire way, all the way until we're able to get rid of more appliances. So now we have a water heater or a clothes dryer that's going to be 105,000 or 35,000 cubic feet, or 35 cubic feet of fuel that we're going to be getting rid of. And that leaves us down to 105,000 BTUs per input. So of course, as you guys all know, that's 105 cubic feet roughly. And if I take a look at that, that is not going to allow us to change our fuel line. So we're going to have to stay with a 1-inch pipe on there. So in my drawing, I'll note that again. So I'll say, all right, whoops, let me go back to that. So that means that the lines are not going to leave until, let me see what will happen. If I go to the 45,000 BTU range or oven, as you can see, I'm going to take the 105 and subtract that. It's left with 60,000. Now, of course, you know that the last appliance is going to be my gas log in that fireplace. So that being said, that means 90. We got 60 cubic feet, which is the longest appliance away from there, and of course, that's going to allow us to switch it to a 3/4 inch pipe. So what that means now is we're going to be able to so we'll be going from 1.25 inch at the main, dropping it to 1 inch. We run that whole way until we make our final branch going to that fireplace, and that'll be 3/4 inch. So now, what do we do for sizing those other branch lines? So let's take a look at that. So we've got 150,000 BTUs in that water heater and boiler. So of course, that's going to be 150. Now what's odd about this particular method that's used quite often is in the longest length, you never leave that longest run. So in this case, I've got 90 cubic feet, or 90 feet row is what I'm going to use. I've got 150 cubic feet, and as you can tell, that branch is going to have to be a 1-inch branch is what we're going to need to do. So we're going to basically look at my application, and I've got a 1-inch branch. So as you can see, that's going to run all the way over to the boiler and water heater. And then individually, now you've got a branch that goes off of that one at 100,000 BTUs. So let's take a look at that one. That's going to also have to be a 1-inch. So in this case, the boiler is going to need a 1-inch line going directly to that. As the 1-inch branch is going there, obviously, as I had mentioned in other YouTube videos, you're going to have to reduce it accordingly when you get near that boiler, because that boiler most likely is only going to have a 1/2 or a 3/4 inch inlet. You just bring it as far as you can, and it should be good. Now, on the example of the water heater, that's a 50,000 BTU appliance. So that's 50, and again, we're not leaving that roll. That allows us to run a 3/4 inch line all the way to the water heater. So that one's going to be 3/4, and again, you reduce it accordingly when you get near closer to that appliance. How about the laundry clothes dryer? So 35 cubic feet of fuel, and that's going to be a 1/2 inch. So now, what about this branch? 45,000 BTUs, which is of course 45 cubic feet. So let's take a look at that one. That's going to have to be a 3/4 inch because the 1/2 inch is going to be a little bit on the light side. So in this particular case, that'll be a 3/4 inch. And that is the application of how to do longest length.